You can imagine what happens if there's a value that approaches 1 and then gets multiplied by itself an infinite number of times. Today in this video, we will discuss this topic. When x approaches 0, 1x gets multiplied by itself infinitely many times. What is the final value? We can express it with this expression. Before we start, I want to introduce this expression, 1x raised to the power of 1 over x, when x tends to 0. These two expressions are remarkably similar. They both involve multiplying 1x by itself many times. So today, let's also discuss the characteristics of these two expressions. And now, you can take a second to hit the like and subscribe buttons. Okay, let's get started. I believe many of you are already familiar with this expression. Here, I'll briefly explain it. Its value is e. E is a natural constant, and its value is approximately 2.718. You might be confused as to why its value is 2.718. Now, we can do some simple calculations. As I set x to a quite smaller value and substitute it into the expression, you'll notice that as I input smaller values, it gets closer and closer to 2.718. So, we can conclude that the expression is equal to 2.718, the same as e. Alternatively, there's another method to prove it. We can use L'Hopital's rule for this, but I won't delve into that here. There are plenty of resources available online to learn more about it. I just used the quickest and easiest method to help you understand. If you want to explore further, you can definitely search for more information on your own. Now, let's move on to this expression. For a deeper understanding, we can split it into two parts, when x tends to 0 from the positive side and when x tends to 0 from the negative side. Now, when x tends to 0 from the negative side, it means its value is closer to 0 from -1, such as negative 0.0001. This implies that 1x equals 1 minus a very, very small number. Therefore, its value will not exceed 1. On the other hand, when x tends to 0 from the positive side, the situation is reversed. It means 1 plus a very, very small number, and its value exceeds 1. Focus on x tending to 0 from the negative side. We know that if numbers smaller than 1 are multiplied together, the final result will not exceed 1. As we continue to multiply them more and more times, you will find that the value approaches 0. So in this case, this expression is approximate to 0. Now, as x tends to 0 from the positive side, when numbers bigger than 1 are multiplied together, its value will become bigger and bigger. If we continue multiplying them, its value will infinitely increase. So, the final value will be infinitely larger. Now you understand these two expressions, but there's a question: why do their final results differ? They both seem to be multiplying themselves. The reason is, in the first case, the larger numbers are not truly raised to the power of infinity, they're only evaluated at a specific x value. In the second case, it truly is raised to the power of infinity, which is why their results differ. What are your thoughts on this? Feel free to leave a comment below.